The General Dynamics F-16XL is a derivative of the F-16 Fighting Falcon, with a cranked arrow delta wing. It was originally conceived as a technology demonstrator, later entered in the United States Air Force's Enhanced Tactical Fighter competition but lost to the F-15E Strike Eagle. Several years after the prototypes were shelved, they were turned over to NASA for additional aeronautical research. Development =SCAMP equals. In 1977, the F-16XL started out as the F-16 SCAMP at General Dynamics Fort Worth. Under the leadership of Harry Hilliker, the original goal of the program was to be a quick project to demonstrate the applicability of supersonic transport technologies to military aircraft. The big wing generated a lot of lift, and typical aerodynamic limitations of delta wings were overcome by the F-16's relaxed static stability. The F-16's electronic flight control system was tweaked to allow control at high angles of attack. The wing was also a big fuel tank which greatly boosted range. The study went on for 2 years. The goal of the cranked arrow was to have a high sweep inboard panel for low drag at supersonic speeds, and a low sweep outboard panel to provide better handling and maneuverability at subsonic speeds. Working closely with NASA's Langley Research Center, the company invested significant internal research and development funds for wind tunnel testing, and that led to the Model 400. It featured all-moving wingtips for roll control and an all-moving vertical tail. These surfaces were actually the horizontal tail surfaces from the F-16A. These surfaces were later dropped as they did not provide adequate control at low speed, high angle of attack. Also, there would have been no provision for wingtip-mounted missiles. The main wing incorporated four-body strakes to enhance vortex generation for high angle of attack maneuverability, negative stability for improved subsonic lift and reduced supersonic drag. It was built around a 40-inch fuselage stretch. Both the large wing and fuselage stretch yielded a dramatic increase in range at all speeds. In 1979, with a strong positive response by the USAF, GD released the Model 400 for a company-funded preliminary design effort. Enhanced Tactical Fighter Competition equals. In 1980, the USAF signed on as a partner, providing the third and fifth production F-16 airframes for conversion. These two airframes became the only examples of the F-16XL. In March 1981, the USAF announced the Enhanced Tactical Fighter program to procure a replacement for the F-111 Aardvark. The concept envisioned an aircraft capable of launching deep interdiction missions without requiring additional support in the form of fighter escort or jamming support. Under the leadership of Program Director Randy Kent, General Dynamics submitted the F-16XL, while McDonnell Douglas submitted a variant of the F-15 Eagle. Though the two aircraft were competing for the same role, they were fairly different in design approach. The F-15E is basically an F-15D two-seat trainer with the back seat station modified to support ground attack instruments, while the F-16XL has major structural and aerodynamic differences from the original F-16. As such, the XL would have required much more effort, time and money to put into full production. Additionally, the Strike Eagle has two engines, which gives it more thrust and capacity to carry more weapons and/or armor. Furthermore, engine redundancy can be very useful for an aircraft whose mission involves operating within the reach of anti-aircraft artillery and surface-to-air missiles, in addition to the standard threats of fighter aircraft and interceptors. In February 1984, the USAF awarded the ETF contract to McDonnell Douglas. The two F-16XLs were returned to the Air Force and placed in storage at Edwards Air Force Base, Mojave, California. Design. The wing and rear horizontal control surfaces were replaced with a cranked arrow delta wing 120% larger than the original wing. Extensive use of carbon fiber composites allowed the savings of 600 pounds of weight, but the F-16XL was still 2,800 pounds heavier than the original F-16A. Less noticeable is that the fuselage was lengthened by 56 in by the addition of two sections at the joints of the main fuselage sub-assemblies. With the new wing design, the tail section had to be canted up 3 degrees, and the ventral fins removed, to to prevent them from striking the pavement during takeoff and landing. However, as the F-16XL exhibits greater stability than the native F-16, these changes were not detrimental to the handling of the aircraft. These changes resulted in a 25% improvement in maximum lift-to-drag ratio in supersonic flight and 11% in subsonic flight, and a plane that reportedly handled much more smoothly at high speeds and low altitudes. The enlargements increased fuel capacity by 82%. The F-16XL could carry twice the ordnance of the F-16 and deliver it 40% farther. The enlarged wing allowed a total of 27 hardpoints, 16 wing stations of capacity 750 pounds each, 4 semi-recessed AIM-120 AMRAAM stations under fuselage, 2 wingtip stations, 1 centerline station, 2 wing heavy wet stations, 2 chin LANTIRN stations. However, the heavy wet stations interfered with up to 4 wing stations. Operational history NASA testing . In 1988, the 2 aircraft were taken out of storage and turned over to NASA for research. The first aircraft was fitted with an active suction titanium glove encasing the left wing and delivered to the Ames Dryden Flight Research Facility at Edwards AFB. Designed and built by North American Aviation, the glove had laser-cut holes that were nominally 0.0025 in diameter. Distance between holes varied between 0.010 and 0.055 in depending on the suction. The glove covered over 5 FTA squared of the wing. It was intended to suck away turbulent airflow over the wing, restoring laminar flow and reducing drag. The aircraft was also involved in testing sonic boom characteristics, takeoff performance, and engine noise, for NASA's Civil Transport Program. The second aircraft had its experimental engine replaced with the General Electric F-110-129. It accidentally achieved supercruise, a design goal of the F-16XL that was never attained in ETF testing, when it reached Mach 1.1 at 20,000 feet on full military power. It was mounted with a passive fiberglass and foam glove on the right wing to examine supersonic flow, and an active glove on the left wing. This second glove was composed of fiberglass and foam over a titanium skin, and covers 75% of the wing's surface and 60% of its leading edge. The active portion consists the middle two-thirds of the glove, with laser-drilled holes leading to cavities beneath the wing. It was designed collaboratively by Langley Research Center, Dryden, Rockwell, Boeing, and McDonnell Douglas. The glove is intended as a test bed for supersonic laminar flow. The F-16XL Flight Project Office was located at the NASA Dryden Flight Research Center, Edwards AFB, CAR. The NASA Langley Research Center developed and coordinated F-16XL experiments. At the conclusion of their test programs in 1999, both F-16XLs were placed into storage at NASA Dryden. In 2007, NASA approached Lockheed Martin to request a study into the feasibility and cost of returning F-16XL No. 1 to flight status and upgrading it with many of the improvements found in the USAF's F-16 Block 40. This was studied while F-16XL No. 1 was taxi tested at Dryden and given systems checks. However, both F-16XLs were retired in 2009 and stored at Edwards AFB. Specifications. Data from darlingf-16.net, General Characteristics, Crew, 1 or 2, Length, 54 ft2 in, Wingspan, 34 ft3 in, Height, 17 ft7 in, Wing Area, 646 ft squared, Empty Weight, 22,000 lb, Loaded Weight, 48,000 pounds, Max Takeoff Weight, 48,000 pounds, Power Plant, 1 General Electric F-110 GE100 Turbofan, Dry Thrust, 17,100 pound forces, Thrust with Afterburner. 28,900 pound forces. Performance, Maximum Speed, Mach 2.05, Cruise Speed, 600 mph, Range, 2,480 nmi, Service Ceiling, 50,000 ft, Rate of Climb, 62,000 ft min, Armament, guns, 1 20 Euro MM61 Vulcan gun, hardpoints, 17 pylons with a capacity of up to 15,000 Euro lb of payload. See also. Related development, General Dynamics F-16 Fighting Falcon, General Dynamics F-16 Vista, aircraft of comparable role, configuration and era, McDonnell Douglas F-15E Strike Eagle, Saab 35 Draken, Lockheed Martin FB-22, related lists, list of fighter aircraft, list of military aircraft of the United States. References. Citations Bibliography Darling, Kev, F-16 Fighting Falcon, Combat Legend, London, Air Life, ISBN 1-84037-399-7. Jenkins, Dennis R. Landis, Tony R., Experimental and Prototype U.S. Air Force Jet Fighters, MN, U.S., Specialty, ISBN 978-1-58007-111-6. External links, F-16XL, DFRC-1, NASA, Photo Gallery No. 2, F-16XL Experiment Report, Dryden, NASA, December 1999. The Revolutionary Evolution of the F-16XL, Air Force Magazine, November 1983. NASA could put the F-16XL back in the air, Flight International, 2007. Harry Hilliker, father of the F-16, Code 1, July 1991, Boer, Joseph Joe unregistered trademark, F-16XL, ATT, F-16XL in flight. https, www.youtube.com/. Watch ?V = LOF54B1ZOFI